a new variable has entered the ecosystem. Today, we're conducting an analysis of the Qwen Image 251 model. The objective is to determine its operational capabilities and, more importantly, its strategic implications. So let's get right to the primary finding because it's significant. The established hierarchy of paid, closed-source systems is being destabilized. A free, open-weight model is now performing at parity with expensive proprietary engines. This means the main barrier to entry for high-fidelity image generation is shifting from cost to compute. Here is our tactical briefing. We will proceed in 5 phases. First, identifying the new variable. Second, validating the performance data. Third, conducting an operational stress test. Fourth, a direct comparative analysis. And finally, we will assess deployment methods and strategic implications. So, Phase 1. The release of Qwen Image 2512 isn't just another incremental update. It represents a fundamental shift. We are now observing an open-weight, open-source model directly challenging the proprietary engines that have dominated the field. And its impact was immediate and quantifiable. Initial telemetry from global evaluations places this model in the 3rd position. Now, this isn't a theoretical rank. It signifies direct competitive engagement with the top-tier closed-source systems currently in operation. Now, any claim of this magnitude requires verification. We will now move to validate these performance metrics through an analysis of the empirical data. And the dataset for this claim is substantial. This ranking is derived from 10,000 rounds of blind model evaluations. A scale like this ensures statistical significance and provides a very credible foundation for our analysis. And when we analyze this data, a critical finding emerges. The performance delta between the open-source Qwen Image 2512 and the closed-source industry standard is statistically negligible. What you're witnessing here is the real-time commoditization of high-fidelity generation. All right, data validation is complete. We will now transition from data analysis to an operational stress test. The objective here is to assess the model's performance against a set of complex, high-stress generation parameters. These are the input parameters for the test. They've been specifically designed to evaluate the model's handling of difficult variables like atmospheric conditions, specular lighting, and fine-grained detail. The primary goal is to determine if it can eliminate that synthetic AI signature. Let's conduct a forensic analysis of the output. First, observe the dermal texture. You can see pores and wrinkles are present and distinct. Second, anatomical adherence. The body posture is well within expected norms. And third, check the specular reflection. The neon light correctly reflects on the coat and other wet surfaces. The model successfully mitigates common AI artifacts. The model has demonstrated capability in isolation, so the next logical step is a direct comparative analysis against a proprietary control. We will subject both models to the identical prompt to establish a clear baseline for comparison. The results of this side-by-side test are conclusive. The open-source variable Qwen Image 2512 demonstrates parity with the closed-source control in both textural fidelity and prompt adherence. In fact, it shows a significant reduction in synthetic artifacts. The implication is clear. Open source has achieved performance parity. So, having established performance parity, we now turn to the final phase of our analysis, deployment methods and their wider strategic implications. Let's assess its professional utility. Its primary function, of course, is high-fidelity photorealistic image generation, but it has a critical secondary function, advanced text rendering. This makes it highly effective for professional slides and infographics. Our conclusion? The model is viable for any high-demand visual content production workflow. In terms of deployment, you have 2 primary methods. The first is remote inference, which is accessible right now via the official Hugging Face space. The second is local deployment, which involves a direct installation for any operator with dedicated compute resources. This entire analysis leads us to a final, critical question that reframes the entire competitive landscape. Access to this level of high-fidelity generation was once a function of cost. It is now a function of compute. With this paradigm shift, what becomes the new strategic advantage?